Alright guys, we're back. Part 4 of our gronk droid demo. I think the last video cut off, it hit the 15-minute mark and it was done. That's okay, it was just taking way too long anyway, so all I did was go through and just make sure most of the edges were set how I wanted them to be set. And now that I say that, I'm noticing something weird here. And then, so make sure your model is cleaned up, and we'll probably uncover more stuff to clean up as we go. Yeah, okay. As we start to do the UVs, so I'm gonna go to UVs now. This is good enough for me. Like I said, it was just gonna be a quick and dirty model. There's a lot more detailing we could do, obviously, and beveling of edges and stuff, but you know, this is for a low poly game asset. This is probably, you know, within reason. And so now what we're going to do is move on to the UVing phase, and this is probably the part that's going to be less familiar to you guys. So I'll try to be a little bit more verbose when I'm, you know, kind of going over what I'm doing. And again, I mentioned this before, but this is in Maya, and the tools are going to be different in Max, but there should be equivalent tools. And I'm going to include a link to some video tutorials on UVing in Max. So through those tutorials, if you're unfamiliar with the tools, you'll be introduced to, you know, tools that are roughly equivalent to the tools that I'm going to be using. And then the really important thing is just conceptually understanding what UVs are, how they function, and the approach to generating them. And so the first thing I'm going to do is assign a shader to the whole thing. I'm just going to use a Fong. Kill my history. Name this gronk map. And then I'm going to plug a checkerboard. So Maya has this checker node I can use, but I'm just going to plug in a texture as checkerboard because I'm not sure if Max has that. I'm guessing it does, but I'm going to include a checker texture in resources for you guys. And now you can see, let's select this and let's look at our UVs. Let's turn the image display off. So these are our UVs, and what our UVs do is basically define how this checker texture is applied to the surface of this model. If you think about it, if you have a 2D image and it gets applied to a 3D model, the computer needs to know, well, how does that work? Well, how does this get applied? And you're going to, as an asset creator, you're going to want to be able to dictate how that gets applied to the model. And so what we use are what are called UVs. And they're a representation of the mesh, you know, vert for vert, edge for edge, face for face, in 2D space. And what that means is, imagine it like you're unwrapping this model to lay flat, as if it were like an origami. Like if you had an origami gronk and you needed to return it to being paper, you would unfold it and lay it out flat. And so that's the process we're going to use to generate these UVs. And generally, so when you create UVs, you know, these objects already have UVs associated with them, but these are completely unusable. Like you can tell by, and this is the reason we put the checkerboard on. The scales are all different. They're smeary. If you wanted to paint a texture, you would have a very hard time painting a texture that made any sense, because, you know, these UVs are so wonky and overlapping. And so what I'm going to do for this model is I'm going to lay these UVs out in what's called the 0 to 1 space, and that's from here to here. The square is where that is basically one of the texture, and the texture repeats endlessly in all directions, but that's the space where it doesn't repeat. I don't know if that makes any sense. But you can see that, so here is our texture. It's a square. And it, even though it doesn't display it, it repeats endlessly in all these directions. And so what I'm going to do is I'm going to put all of our UVs non-overlapping into the 0 to 1 space. And that way, if I paint a texture, there won't be any overlapping. There's another approach to doing this using tileable textures, which are textures that repeat without seams, and then applying to them to the model. But for this demo, I'm going to do a 0 to 1 space texture. And so to get these textures whipped into shape, we do what's called a projection. And it's sort of like, if you can imagine it, it's like taking a camera shot of, various directions. It's actually, we'll do a planar map, and you could do it from, so you can either choose the axis, and I'm going to do a planar map from the y-axis, and look how our UVs change. Now it's like as if a camera shot straight down and generated the UVs based on that. And so all of the faces facing straight up look good because they are mapped as close to being a face map as possible. But the ones on the sides are all smeared and messed up because viewing this from up here is not very representative. And so that's a really weird way of putting it, but the idea is what you want to do is map the UVs so that they're perpendicular to your faces. And the best way to do that is through a series of projection mappings and then cutting. And probably the easiest way to sort of describe that is to just do it. I'm going to separate this too, so that we have these guys are separate. So hide all the rest of these. Let's use this as an example. We've got our projection from the top. I could project it from any side. Like I could project it from z-axis, and now the front looks okay. I could project from the y-axis, x-axis, or I can project it from the view of the camera, which would project it based on my perspective view from the viewport. You can see how that corresponds to this. And so what I'm going to do is project it from one view. I'm just going to pick a view, and then I'm going to unfold it from that view. Probably the easiest view for this object. And you basically just have to make a judgment call, like what's going to be the easiest. I could do it from all these other views, but I feel like, just based on my experience, projecting from the top and then unfolding it is going to be the best approach. And so I projected it from the top. Now I need to go through the process of unfolding it. And the way that works is cutting edges and then using the unfold function. Now what I could also do is select these faces and reproject them based on what works for them, and then sew the pieces together after the fact. In fact, maybe I'll demonstrate that. So projecting on the Y looks great for the top, but it looks lousy for the sides. Now what I can do, like I said, is use the tools to cut and unfold that. But if you don't know how to use those cut and unfold tools very well, you could just kind of go really old school brute force approach and just reproject this. And so I'm going to use a camera projection. I'm going to sort of set this up so it's roughly perpendicular. And then I'm going to camera project this. And now I've got a separate piece. And it looks better. And what I can do after that is kind of sew these edges together to get rid of the seams. And so when you're UVing stuff, it's a constant balancing act between stretching and seams. Like, this is perfectly seamless. There aren't any seams in here, but there's a lot of stretching. And this, for the most part, has no stretching, but it has a seam. And so you kind of have to balance those things out. And it's, you know, at the end of the day, it's just a judgment call. Okay, and so I'm going to unfold this other piece using the unfold tools. And to do that, well, actually, I'm going to make this a little easier on myself. I'm going to remove this guy and do it separately. So I'm going to go to my UV toolkit and I'm going to cut. And then just pull in the side because I can already tell it's going to give me troubles. I'll address that separately. And the same goes for this. So I'm going to go ahead and select the edges. And then the cut and sew tool works on edges. I cut. And it's almost like, really like working with cloth in a way, like as if you were sewing. And that's probably why they use the sewing analogy to describe these. And so I'm going to want a seam on this edge. I sort of already know that because that's how it would have to, that's where the seam would have to be in order to unfold this thing. And the same goes with this edge. So I'm going to select those and then I'm going to cut them. And now I've got a seam there. And then I'm going to unfold. So I'm going to select, and this is one of those cases where your tools in Max are probably going to work a little differently, but I'm 99% sure Max has an unfold function, and although it may work differently than Maya, it should still get you where you need to go. And so in Maya, I'm selecting the vertices I want to have pinned, and then unfolding it, and you'll see how it knows sort of how stretched the image would be on a set of UVs. It can calculate when UVs have a lot of stretching or smearing, when they're not representative of the face, and I'm guessing it probably does that by measuring the area of the face itself versus the area of the UVs, and if there's a discrepancy, it realizes, hey, wait a minute, there's clearly some stretching going on here. And so what it does is it unfolds it to the best of its ability, and these unfold tools have gotten really great, so that now our UVs are looking much better. And so what we're going to want to do is sew this guy back in place. And we've got a little tab here that is not where I want it, so I'm going to go ahead and cut that. I'm going to stitch that back together, and then we're going to do the same for these guys. And now, for the most part, I have a pretty decent start on my UVs. Now, I didn't address this little box in here, but I'm just going to address it in here in the UV editor and just give myself, because I know there are faces in here, and even though that this is a little bit wonky, it's an okay compromise versus having additional edges and pulling this part out. It's kind of a not a super important detail. And so those are the judgment calls you make. What details are important? How many seams do I want versus how many different shells do I want?